So hello everyone, thank you for attending this talk. And today I'd like to talk with you about something that probably most of you use underneath the tools that you use every day. Probably most of you use Spring 5 and Webflux. Probably some of you use Vertex or Ratpack, and maybe some of you use Elasticsearch or Apache Cassandra. All these things have something common, and this is NETTY. Underneath these tools there is NETTY, and today we implement something in a pure NETTY, and it will be a WebSocket application. But before we start talking about NETTY, let me share some story why it happened that I had an opportunity to work with NETTY in the production project. So, our company handed over a project from a third-party company, and technical people that were attending this handover, they said that this project is not in a good quality. But the manager reaction was something like that. Then they hired me, and I was the first developer on that project, and my reaction was quite different. Well, this project was in really poor. This project had a really poor quality, and it was really hard to maintain. But the architecture of this project was quite nice. The nice tools were used there, so I thought that it's a good opportunity to learn something new. And of course, it handled a lot of clients, so it was a good challenge. But I didn't know anything about NETTY, so I needed to read some books, read some tutorials, and learn how to write applications in a pure NETTY. And it was a WebSocket application, so let's talk a little bit what are the WebSockets. Well, if we have a typical communication between client and between server, the client sends a request on which server responds. If you want to change it, we can switch into WebSockets. To do that, client needs to send a request on which server responds with an upgrade, and with that, we are able to upgrade our connection into WebSocket connection, and with that, client and server can talk to each other, and this communication is full-duplex, so it means that both of them can talk at the same time. If you are not using WebSockets in your application, then you probably use WebSockets underneath the tools that you use every day. The example is GitHub. When you are making a pull request and you ask your colleague to review your changes, and you go for a coffee, and well, let's say that your pull request was so small, so your colleague approved it really quickly. You back with a coffee, and you, without reloading a page, see that your pull request was approved. Why did it happen? Well, it was because of the WebSockets. If we take a look on the network, we can see that there is a magic HTTP status one-on-one, which means switching protocols. And if we take a look what's the connection is upgrade, and this upgrade is upgrade to WebSockets. What's also similar to the WebSockets, but it's not WebSockets, is a two-way binding in, for example, AngularJS framework. Well, if you change something in one place, it's immediately changed in the another place. And it's just a web browser. It's just a front-end framework. But with WebSockets, you can achieve similar behavior between client and server communications. So, if you did something with WebSockets, some tutorials, it probably was a chat application. So, don't worry, today we won't implement the chat application once again. We will implement something different, and it will be simple sport application. So, different case to implement something in WebSockets, and we will implement it in a pure NETTY. So let's talk about what is NETTY. Well, NETTY is async event-driven framework, and it's open source. If we go to the GitHub, we can see that NETTY is with us for a long time. We can see that there is a lot of forks, and the project is quite popular and still developed. This is from February, but currently in October, it's still in developed. The amount of forks increased, and the project is more popular. So NETTY is still in use. And we said that NETTY is event-driven framework, and these events are handled by event loop. So let's talk about Let's talk about little about event loops. If we have a client which is sending a request, this request is translated into event. It can be one event, it can be multiple events, but then we have an event loop, which is single thread, which takes an event and it can delegate work to the workers, and then event loop is ready to take another event. If workers finish their job, it's also translated into event, and it can be sending response back to the client. So in NETTY, we will have such event loop, but we will have an event loop group, so it will be a little bit more complex. In NETTY, we will implement HTTP server, which will use non-blocking I/O, and we will use here Java non-blocking I/O. You can use something else. You can use blocking I/O, or you can use Linux-specific stuff like EPL. I didn't use it, but it's achievable. We'll talk about it later why. We will implement asynchronous communication between client and between server, but also in our application, everything will be asynchronous, so we will return immediately, and we will need to handle the asynchronous problems inside our application. Let's say that our application will be used by a lot of clients. So in this case, asynchronous gives us, and non-blocking I/O gives us high performance because we can use our resources best. But also high performance was achieved another ways. There are some native solutions, and the first one is what I said, that you can do something in Java that is specific for operating system, and it was because there are some native solutions, but also native solutions were implemented using JNI, which is Java Native Interface. There are also some low-level solutions because they wanted to help garbage collector with reference counting, for example, for their own implementation of bytebuf, which is a little bit more enhanced. Don't worry, today we won't use the Java Native Interface, but I'd like to say that they use it in NETTY underneath. Who use NETTY? At the beginning, I said that if you are using Spring with Webflux, then you are using NETTY, and it's true because Pivotal in their Reactor project, they use, of course, NETTY. But NETTY is also used in such big companies like Apple or Google, and biggest social media providers like Twitter, Facebook, Instagram, they also use NETTY. But NETTY is also used in a technical solution, so for example, Vertex or Ratpack, and also Apache Cassandra Elasticsearch use NETTY. If you want to see who else is using NETTY, well, who else use NETTY, you can go to the NETTY site, you can check adopters, and there is also an information which way NETTY is used in that companies, in that project. What are the alternatives for implementing a WebSocket communication? Well, you can use just the Spring, but in some cases you will lose the power of your application, and sometimes it won't be sufficient for your problem. You can use Jakarta EE directly, so the old Java EE, and probably this solution will be recommended by Adam Bean. But if you are, for example, Node.js developer, or you are mixing technologies in your microservices stack, then you can use the socket I/O for Node.js to implement WebSockets. So we said that NETTY is based on events. Events are handled by event loops, but then events go through the channels. So let's talk about channels, what the channels are, and what stuff is connected with the channel. Well, we will have channel pipeline, in which will tell us what is the path for an event that event need to take. In this pipeline, we will have channel handlers. So in pipeline we will have multiple handlers. In these handlers, we can use the channel context on which we can do various operations. We will talk about it later. The channel can have a state, so channel can be active, inactive, idle. We can handle it, of course, in handlers. We can group some channels to not send messages to all channels separately, but we can, for example, group it, and we will use it in our application. And we will do stuff asynchronously, so we will have a channel promise. So if we will have a need to do something one by one, then we will need to do it through the promise. And it won't be the Java promise, so it won't be the completable feature, but they have their own implementation of promise. So what's the channel pipeline once again? Well, the channel pipeline will be initialized by the channel initializer. So if you want to see the base pipeline for each channel, you need to check the initializer. In this channel pipeline, we will have channel handlers. So event will be passed through this event channel handlers to be handled by one of them or multiple of them. And it will be connected with inbound and outbound traffic. And if we are talking about inbound and outbound traffic, at the beginning, there will be some decoders to decode the binary data into object data. So we will have opportunity to use Java objects in our handlers, which will be more comfortable for us. So channel pipeline will be each channel will have their own pipeline. It will give us interesting stuff that we will talk about later. So channel pipeline will also represent the flow that event needs to take. And because each channel will have their own pipeline, then we can modify the pipeline. And more of that, we can modify it dynamically, so during some operations in a handler. We can also specify some executors for the channel pipeline, so it's it's a way to implement multi-threading there. Then we will have the channel handlers, and we can use it for the data conversions. So these are the encoders and decoders, and we can use it the same way how we are using converters in Spring MVC to use our own objects. But basically, we will delegate our business logic there to our services. But in our application, we will do it just directly in handlers. So similar way how we are not implementing our business logic in Spring MVC controllers, but we are delegating this business logic somewhere else. But the same way we can do it in handlers. In handler, we can also handle channel changed when the channel states change, because channel can be registered, unregistered, active, inactive, idle, and we can handle it in handler. And handler can be shareable through the pipelines, but be careful with that if you're using multi-threading. So we will have interface channel handler, but we can distinguish inbound and outbound handler, and we can also use adapter to not implement everything. But in fact, we will use something different. We will use a simple channel inbound handler, which will simplify some operations in NETTY. We will show it at the end. Then we will have a channel handler context on which we can access the whole channel. With the context, we can write and flush, and we can do this operation as a one, or we can do it separately, and sometimes it can be optimized. We can access the pipeline, and we can modify the pipeline through the context, and we can fire some event, for example, file channel event, for example, to pass our event to the next handler. And the context will be passed through the handlers, so it will be in one-to-many relation with handlers in a pipeline. And don't forget, of course, to close our channel. Then we will have a channel group, so we can group some channels if we have such need, and do operations for the group, not for the one channel, and we will use it in our application. So we will have some groups of channel which will represent the favorite sport teams that user can subscribe. So if something will happen, some sport event will happen for a specific team, then we will send event to the group, and it will be propagated to all channels which will be in that group. Just this way. And now, finally, it's time for a demo. So let me switch screens. Okay. The code will be available on GitHub. I will send the link at the end. But now we will work in IntelliJ. But let me do just one more thing. Retina. Okay. Let's go to the presentation mode. Okay. Is this code visible for you? Okay. So what we have here, basically, we have here a main function, which is nice. And then we have an event loop group, so something that we described at the beginning. And this will be the non-blocking event loop group. And we specified just one thread for the boss group. Oh. Whoa. What happened? Okay, maybe not with the presentation mode. So we will have a boss event loop group and the worker event loop group. They will be combined together in server Bootstrap because we are preparing this server Bootstrap, and we are grouping these event loops groups. So here we are grouping a boss group and the worker group. Then we are specifying what will be the base channel, and the base channel will be, of course, the Neo socket server socket channel, so it will be non-blocking. Then some handler for log some stuff. We will show it on the screen. And here we have a base channel initializer, so we will go here soon to check how our channel pipeline will look like. But what will happen next, where we are just binding the host and the port, and we are syncing because everything is asynchronous and we don't want our application to end with the main thread, so we are blocking here main thread, and when we unlock it, then we will need to close it, and of course we will wait for that operation. If something wrong will happen, then we are handling exceptions. But now let's go to the base channel initializer. Whoa. Strange, okay. So what we have here at the beginning? Well, we have our channel initializer, and at the beginning we have a HTTP server codec to encode and decode data to use just HTTP objects. And then we have a HTTP handler. So let's take a look how this HTTP server handler look like. This is our own class. And as I said, we are using here simple channel inbound handler, and with that we are able to use the HTTP request interface, which is really useful because you can access all the HTTP stuff here. So for example, the HTTP method. And here, for example, we are saying that we are serving for now just the GET request. So we are not accepting any other requests. Then we are sending the bad request. But if the request will be valid, so we can access the URI and check if it's hello. So if it's hello, then we will prepare a positive response. And we can write this response through the channel handler context. We can check if there is a keep alive connection, so do some other stuff. And at the end, we can flash. So this is an example that we can do write and flash as a separate operations. But for example, while we are sending a bad request, we are doing write and flash together by sending the bad request. So this is the basic HTTP application. So let's run it and check if it's work. Okay, there are some logs, but we can check with the curl if everything is working. Hello. And we said that our server is working, is responding with hello. But we said that we want to be able to handle WebSocket frames, WebSocket communication, so we will do it in another step. So let me turn off the server. And I've got prepare GitHub branches. So we are now on the step 1. Then I can check out to the step 2. OK, we are now in the step 2. Something changed. And we have 2 additional handlers. We have a WebSocket frame handler and WebSocket handshake handler. So let's take a look on our initializer. So we have our pipeline, and something additionally is added here, the WebSocket handshake handler. So we are decoding the HTTP. Then we are checking if there is a handshake. And if it's not a handshake, then we are serving the HTTP request like we did before. But let's take a look what's here. Here we also use the simple channel inbound handler because at the beginning of the handshake it will be HTTP request. And we are checking headers if there is a need to upgrade connection to the handshake. So it's basically checking the connection and upgrade if it's WebSocket. And if it is, then we are handling a handshake. If it's not, then we are passing our event to the next handler, which in our case is HTTP server, HTTP request handler. But let's take a look on that handshake. And what we got here is we are modifying pipeline through the context. So we are accessing the pipeline, and we are replacing the current WebSocket handshake handler with the WebSocket frame handler. Because if we will do the handshake, then for this channel we won't need anymore the handshake handler, but in this time we will need a WebSocket frame handler. And for now we will just basically handle simple WebSocket frames. In next step we will do something more here. So let's go to the handle handshake. For handling handshake, we just need to prepare a valid URL, but we got a class to handle this handshake. We can specify some sub-protocol, something else, and if handshake will be successful, then we will log it. And here we are using the channel promise, because here we return immediately, and if this operation will be completed, then we will log on our server that there was a handshake. So let's check this example. Hopefully without this green screen instead of blue screen. Okay, so we have our server. So now we need to establish the WebSocket connection. So I have a curl for that. Okay, so we are doing a curl on localhost, and on localhost on the same port, so to our server, but we are specifying the handshake headers to handle this handshake on the server side. So let's do it. And what we see is the magic HTTP status, which is 1-on-1, which is switching protocol. So now we switch our communications into WebSocket. So now let's try to handle some WebSocket frames to do some WebSocket communication. So let me go to the next step. Okay. And in step 3, what we will have we will take a look on our WebSocket frame handler. Now we are able to handle also WebSocket frames. So basically we are taking a text from these WebSocket frames, and we here establish some protocol. So the client will send us an operation that client wants to do. So the first parameter will be the operation. Then there will be the delimiter, which will be simple mark. And after that, there will be a parameter. So, for example, name of the team that user can subscribe or unsubscribe. If this protocol would be unrecognized because there will be not enough parameters, then we will send a response. But if everything will be fine, then we will do nothing for now, because we have some implementations for handling subscribe and unsubscribe, but they are not implemented, so just null is returned, but just in this step. So let me start our application. And I forgot to show that there was a handshake, but we will do it again. But for now, for this example, we'll do it through simple page. I'm not the front-end developer, so it's not so nice, but here we have possibilities to send the subscribe request, unsubscribe, and here's outputs from our server. So if I not specify any parameters, the response is not enough parameters. Of course, it's with the typo, because this typo is also here. So we see that this is the right response. But we can specify here, for example, a name of our favorite team. So for example, Manchester, and everything is fine. And we will do it. We'll do more stuff in the next step. But let's go to our server log, and we see that there was a handshake. So our log that was there, and of course we are logging here the WebSocket frames. So what was at the beginning? At the beginning, that was a subscribe operation with the parameters, so there was not enough parameters, but then it was correct, so we send nothing. But in next step, we will send something to the client. So let me go to the next step. Step 4. Okay, so in this step, the business logic is enriched. So we are just now handling the subscribe and unsubscribe operation. So we can go here and we can check how subscribe work. Well, we have a subscribe handler, which is also sending a response. So it's our simple business logic. But here, we are just keeping in memory subscriptions, which is basically the code of the team, and then the channel group. So here we will group some channels that will be connected together through this team name, what we will have here. So basically, if someone is making a subscribe, then we are checking if it already exists. If yes, then we are adding this to the group, and if not, then we are creating the new channel group and adding this channel to this group. And we are also specifying executors here. So that's the subscribe. Similarly, the unsubscribe operation is done. So now check how it works, but one more thing to show you, our HTTP handler. We have an endpoint for simulating a match. So if we did a pause request this time, which will be with simulate URI, then our application will simulate a match event. So it will be penalty, a red, yellow card, or a goal. And then we will send it back to subscribe client. And at the end, we will close. So let me run this application. Okay. So now we can open multiple windows. So it will be the first one. Maybe I will copy. It will be the second one. We see that there is a response that WebSocket connection is open. So on the first window, we will subscribe to, for example, Manchester team. and now the response is correct. We are confirming that the subscription was done. And on the second window, we will subscribe, for example, to Liverpool, so different subscriptions. And now we will simulate our match, and we can do it. We can do it more continuously. So I will run watch here. Okay. So now we are simulating match events, and as you can see, the clients are receiving the different events. We can unsubscribe, so for now we shouldn't be able to receive any requests, but we can also subscribe here to the same team. So from that time we should be able to receive the same events for Liverpool. So basically that's how our application works. But if we will close our server, then we see that in both windows we handle that the WebSocket connection was closed. So we are well able to, of course, log it. So that was an example with application with handling the text WebSocket frames. So let me go back to the presentation. Okay, so it was our demo. So let's summarize what we did. We had at the beginning HTTP codec, which encodes our HTTP binary data into our HTTP request. Then we had a handshake when we were checking if there was a WebSocket handshake. If it was, then we replace this handler with the WebSocket frame handler. So we were able to handle WebSocket frames from that time. And if not, we are just serving the HTTP request. How we can extend this application? Well, as in Spring MVC, we can add some exception controller. Here we also can add some exception handler if we not handle an exception in our handlers. So it can be one general exception handler at the end. At the beginning, we can add some idle handler to check if our client is active or if it's idle, so we can, for example, close the connection or do something else. We can also extend this HTTP codec because it was, we used the NETTY object here, but we can prepare our own encoder and decoder to use our own object if we have such a need. We can add also here some aggregator to aggregate the events some way. And of course, what we can basically do, we can extend these WebSocket frame handlers and these HTTP handlers. So we can do a lot of stuff here with this application. So let's summarize what we know about WebSockets. Well, as HTTP, WebSockets are based on TCP. So this is the different kind of communication between client and between server. To achieve that, you need to upgrade the connection to the WebSocket. So there need to be the HTTP one-on-one status, which means switching protocols. And with that, you can achieve a real-time communication between client and between server. So you can, for example, transmit a live event. So it's something like asynchronous communication between client and between server. So that's the good stuff. But there is also something that we didn't cover. Be careful about the security, because with the WebSockets, there is no such thing like semi-origin policy. And in our application, we didn't implement any tokens. And of course, I also saw an applications where the security missed these tokens. So be careful with that. There is also a good practice to add some tokens to the request. But also the load balancing can be tricky here, because if we have multiple instances, then we want the one client to be handled each time by the same server. So it can be tricky, but some load balancers are handled as situation. But of course, there is something like TCP connection exhaustion. So if you reach above 65,000 connection, then it's a limit of TCP connections. So we need to be careful with reaching that limit of the connection. So let's summarize what we know about NETTY. Well, we saw that NETTY is async event-driven framework. We were handling events inside. We use the non-blocking I/O, so we were able to use our resources best. There were some specific solutions. So to start working with NETTY, there is some learning curve, and there are other specific solutions if you go more deeper, because you can use these byte buffs, and this you need to take care of the reference counting. But NETTY is open source. You can take a look how it was implemented, and many solutions where NETTY was adopted to other solutions. So you may not have needs to use a pure NETTY, but if you want to, for example, do something with the UDP protocol, so you may want to use NETTY. And what's worth mentioning here that if you are using Quarkus, there is a NETTY Quarkus extension, so you can do it application on Quarkus with NETTY. Be careful with NETTY 5, because you may find a NETTY 5. This project was abandoned. The current version is NETTY 4.1, so be careful with that. And what to do next if we know how to implement application with NETTY? Well, you can go to the GitHub, check the source code, but you can also check any useful information in Wiki. You can read interesting book written by Norman Maurer, which is taking care of NETTY. NETTY in Action, really nice book about NETTY. As I said, you can use the Quarkus extension. But if you want to implement a WebSockets different way, you can use just the Spring Boot starter for the WebSockets, or you can use WebFlags to do it in the reactive way. So we are on the IT conference, so we need to tell something about being reactive. Well, there is RxNetty prepared by Netflix, so we are happy. But if we take a look there, well, it's no longer supported. So it's not good information, but don't worry. There's also Reactor NETTY, which in compared to RxNetty is still in use. And the Reactor NETTY is used in the Spring WebFlags. So if you are using WebFlags, then you are using Reactor NETTY and NETTY underneath. So thank you for your attention. That's all what I got for you. Remember that your vote is important, so I will be thankful for any feedback on inventory. And if you got some questions, then I'm happy to answer them now, or you can contact me on LinkedIn, Twitter. I'm from Katowice, and Sailisha Juk, and the code will be available on GitHub. So thank you. Are there any questions?
Anybody?
Okay, so thank you. And sorry for my English, because I was a little bit stressed, but I hope it was understandable. Okay, thank you.
That was the last talk at JDD. Please remember that in 20 minutes there will be the closing ceremony. So stay with us, don't go anywhere, and see you at this closing ceremony.